Welcome to today's video where I'm going to go through how trigonometry is played out when you're using angles that are sketched on the Cartesian plane. You've been introduced to trigonometry back in grade 10, probably be the first time you saw it. Just to refresh your memory, so trigonometry refers to the situation where you have right angle triangles in particular. You probably have even looked at non-right angle triangles, but let's suppose you have the hypotenuse. You have some angle marked here as your acute angle. Let's say that one's theta. And then you have your opposite. And you have your adjacent side. So you should know at this point, before you get to trying to do trigonometry on a rotation angle, you should know at the very least, you should know your 6 trigonometric ratios. And your 6 trigonometric ratios are the sine of theta, which is always the opposite side divided by the hypotenuse, the cosine of theta, which is always the adjacent side divided by the hypotenuse, and the tangent of theta, which is the opposite side divided by the adjacent side. And these are referred to as the 3 primary trig ratios. Trig being short for trigonometric. In addition to those, you should know what are called the 3 reciprocal ratios. Now these ones are self-explanatory once you see the first one if you're not familiar with these, but you should be. You should have seen these somewhere. Every primary trig ratio has a reciprocal ratio. The reciprocal of the sine ratio is the cosecant ratio, abbreviated CSC. And as the name states, you just take the reciprocal. So you flip it, hypotenuse over opposite. The cosine ratio has a reciprocal ratio called the secant ratio. And the secant is the hypotenuse divided by the adjacent. And the tangent ratio has a reciprocal ratio called the cotangent ratio, and it is the adjacent side divided by the opposite side. One thing I try and get students to use as a bit of a memory device here is nobody ever mixes up the reciprocal of the tangent ratio, cotangent, pretty much self-explanatory. You'd be surprised the number of times students get these wrong, though. The sine ratio, its reciprocal is cosecant. The cosine ratio, its reciprocal is secant. I'm just going to highlight the first letter of each of these. I want you to notice something. The reciprocal ratio for the sine ratio does not start with the same letter. It starts with C. The reciprocal of the cosine ratio does not start with the same letter, so don't match up the C with the C. It's cosine and secant, sine and cosecant. So that might help you keep those straight if you mix them up from time to time. All right, so we're going to take this basic stuff that you would have done in grade 10, and we're going to now move this onto our Cartesian plane, which is, Cartesian plane, which is our graph and our rotation angles. Just going to switch these around. Okay, so on a Cartesian plane, we will have something called a reference angle, and we will then be able to create what are called reference triangles. So we start with an angle in quadrant 1. So this is our terminal arm. We've gone through how to create angles. This little angle in the corner would be my reference angle. So that angle down there is referred to as the reference angle. And I'll go back up here. Here's the definition. So the reference angle is an acute angle, so that's important. It's always acute. That means between 0 and 90. That is formed between the terminal arm, that's this blue arm, and the x-axis. So when this was my terminal arm, I knew this had to be my reference angle. It's the acute angle between the terminal arm and the x-axis. Now what that implies is, let's suppose your angle looked like this instead, and your terminal arm was over here, let's say. That would mean that this is the reference angle. It's always an acute angle formed between the terminal arm, and the x-axis. So this would be my reference angle. Now, on that reference angle, you could draw a point anywhere, it doesn't matter, and it would have the coordinates x comma y, just a regular point you would plot on a graph, right? Over to some x value, up here to some y value, plot that ordered pair. If you did that, that would make this side of the triangle be whatever number x is, and that would make this side of the triangle be whatever number y is. So for example, imagine this was the point 3, 5. That would mean it's 3 units across here and 5 units up here in this triangle. When you put your ordered pair and then you draw in your it has to be drawn with a vertical line down to the x-axis, you will create what is called a reference triangle. And then once you have this reference triangle, all of the trig ratios that you've learned before will now still be in play, but rather than referring to them as opposite, adjacent, and hypotenuse, we will use x, which will take the place of adjacent, y, which will take the place of opposite, and r, which will take the place of our hypotenuse. So then we go to our ratios and we rewrite them now. So on the Cartesian plane, when you're talking about x, y ordered pairs on a graph, the sine of an angle will always be the y coordinate divided by the r coordinate, because sine is opposite over hypotenuse. The cosine of an angle will always be the adjacent over the hypotenuse. I don't know if I said that last one right. Sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Tangent is the opposite over the adjacent. So it would be the y coordinate divided by the x coordinate. And then of course you have your 3 reciprocals. Scroll down a bit so you can see this. So the reciprocal of sine is cosecant. So you would flip this over. Now it's r over y. Secant is r over x. Cotangent, is x over y. Now, you need to study and know these. So you need to know that the sine of theta is y over r, cos of theta is x over r, tan of theta is y over x. Now, you really don't need to study these ones. As long as you know the name of the reciprocal, and you know this one, well, you know you just flip it over. So I know that reciprocal of sine is cosecant. I know sine is y over r, so I know I just have to flip this over and make it r over y. X over r, its reciprocal becomes r over x. Y over x, its reciprocal becomes x over y. I do have a little memory device that I've been using for years to try and keep track of this. The sine, psi, if I say the word psi and I kind of drag out that middle part of it, psi, that sounds like the letter y. So then I know psi, y. Cosine goes with x. Well, there's no little memory device for that one, but there's only 2, x or y. So if the psi goes with, the y goes with sine, x goes with cosine, tangent is both of them, the y divided by the x. Again, that may or may not help you, but that's kind of what I use to at least make sure I can know that psi goes with y. Now, how does this play out if my angle isn't in quadrant 1? So now all of a sudden, let's draw this over here, right? So now this is my reference angle over here. I make my triangle by drawing it down always to the x-axis. And let's suppose this ordered pair now was -3, 3. Let's use a different number. Let's go -3, 2. Now that would mean this side, which is my x, is -3. This side, which is my y coordinate, is 2. And my r value, which you'd say, well, I don't know what r is. Well, these are always going to be right angle triangles. So we can always find r using Pythagoras Theorem. So if I needed to get the r value, it would be, so r squared would equal negative 3 squared plus 2 squared. So r squared would be 9 plus 4th, which is 13. So r would be the square root of 13. So this side is the square root of 13. Now, you may look at this and be saying, well, how can you be calling the length of a side negative? And I'm not really doing that. But what I am saying is that because of where I've drawn this angle, the sine of theta is the y coordinate. Up here are the y values. These are your y values. They're always positive. Our hypotenuse, r, this is important, it is always positive. So we never, ever, it doesn't matter where we draw the angle, put a negative on our hypotenuse. Now, depending on where we draw it, we may put negatives on our adjacent and our opposite. All right, so if I look at my ratio, sine of theta is 2 over radical 13. The cosine of theta would be negative 3 over the square root of 13. And the tangent of theta, which would be the y divided by the x, right? So the y over the x would be 2 over negative 3. Whoops. If I needed my reciprocal ratios, cosecant would be radical 13 over 2. Secant would be negative root 13 over 3. And cotangent would be negative 3 over 2. You just take the reciprocal. So I want you to notice what happened. Well, all of a sudden, my trig ratios, this one switched to negative. They may say, well, why is the cosine negative over there? Well, the reason the cosine is negative is because when you draw your angle, any point, it doesn't matter where you pick the point, anywhere in this quadrant, I picked an ordered pair, x, comma, y. In order for you to plot a point that ends up here, the x value would have to be a negative number. Well, if x is negative, based on what I know about my trig ratios, this should be negative and this should be negative because they're the ones that have the x in them. And now this one, x is negative, r is always positive. Now I'm talking about this quadrant. Y is positive, r is always positive. So that's why any angle in quadrant 2 would have a positive sine ratio. Cosine in quadrant 2, x is negative, r is positive, so cosine's negative in quadrant 2. Tangent is the y divided by the x. Well, the y's are positive here, and the x's are negative. So in this particular quadrant, the tangent ratio, we said this would be negative, and this would be positive. We would get a negative tangent ratio. I'm just going to erase, leave those, I guess. Okay, so I'm going to try and put that all together now, generically here for each of the quadrants. So if we look at quadrant 1, remember, this is your ordered pair, so any ordered pair you pick here, the x will be positive and the y will be positive. Now keep in mind, I'll just jot them down here real quick. Sine theta is y over r, cos of theta is x over r, and the tangent of theta is always the y divided by the x. Now, when I put x, y, and r here, we're talking about these coordinates, these numbers right here. So this is x, this is y. So looking at your ratios, in quadrant 1, the sine ratio, I'm just putting here whether it's positive or negative. So the sine ratio should be positive because it's positive. Remember, r is always positive, so it's positive over positive. Cosine should be positive number over a positive number. So cosine's positive in quadrant 1. Tangent is the y, which is a positive number, divided by the x, which is also a positive number. And if you're more of a numbers person, for example, if I plot at this point, it could be 7, 3. Well, then x is a positive number and y is a positive number that I'd be filling in here. I could calculate r if I needed it, which would be this distance here, which is always a positive number, and I would get those ratios. Now, when you take the reciprocal, so if you said, what if it's secant instead? Well, secant is the reciprocal of cosine. If cosine of an angle is 3/5, the secant is just 5/3. If the cosine is -3/5, well then the secant is 5/-3. If cosine's negative, so is secant. If cosine's positive, so is its reciprocal. So they don't switch signs. I find sometimes students will mix it up with slope of perpendicular lines, and they say, yeah, we did something with negative reciprocals along the way. That's the slopes of two perpendicular lines. That's not what we're doing. We're just taking the fraction and interchanging the numerator and denominator, but we're not switching any signs. All right. Let's go on to the next quadrant, and let's do the same thing. Now we're going to try and go a little bit quicker here. So the sine ratio, sine is y is positive, r is always positive, so sine's positive. Cosine is x, which is going to be a negative number, divided by r, which is a negative. And the tangent ratio, which is the y divided by the x, will be also a negative number. And again, we're just going to look at this for the primaries. If I needed reciprocals, I would just flip over the corresponding primary. And again, hopefully understand what I mean here by x, y, and r, and the negative and the positive. If you were to plot any point over here, for example, this dot right here could be -2, 5. That's the only way you can get into quadrant 2, a negative x and then a positive y. Negative, positive. In order for us to plot a point and end up down here, I'd have to go negative number, negative number. So for example, -5, -2. -5, -2 puts you down in quadrant 3. So down in this quadrant, let's go through our ratios. Psi, y is negative. Remember, don't worry about r, it's always negative, or always positive, sorry. Cosine is the x over r, r always being positive, so it's negative. And now the tangent would be the y divided by the x. Well, a negative divided by a negative is positive. Last one. So to get a point to end up down here, you'd have to go some positive number, then a negative. So for example, this point right here could be 8, -3. Right? Over 8. Down -3. That would put you in quadrant 4. So if you have an angle drawn in quadrant 4, its sine ratio, because the sine matches up with the y over the r, should be negative. Cosine should be the x, which is a positive, over r, which is positive. And then the tangent, which will be the y over the x, it will be negative. All right, so then that leads to a little memory device that some students like to use. I'm going to show you two. This is what I like. Psi, which I've already shown you, goes with y. Cos is the x coordinate, and tangent is the y over the x. That is how I like to remember where trig ratios are positive and where they're negative. There is this little memory device, which is C-A-S-T. Make sure you start bottom quadrant 4. Start with the letter C and spell the word cast, and they'll call it the cast rule. But I really like this idea better because you're really understanding why the cast rule works, but some students just memorize this little thing and it works. And this is what these letters stand for. I'm going to go up here and show you. I'm going to get my highlighter out, and I'm going to... So I've highlighted all the ratios. I've highlighted only the sine ratio. I've highlighted only the tangent ratio. And I've highlighted only the cosine ratio. I want you to notice the 4 that got highlighted. Sorry, in each of the 4 quadrants, cosine was the only one positive. Tangent was the only ratio positive. Sine was the only ratio that was positive. Here, all the ratios were positive. So if you go down to our acronym that the rule uses, C stands for cosine. A stands for all, S stands for sine, and T stands for tangent. And these ratios are positive in these particular quadrants. Everything else is always negative. Now, when I say these ratios, I'm talking about primaries. So if cosine's positive, so is secant. I'll just write underneath here. Secant also. And this would be all everything is. So sine, its reciprocal is cosecant. And tangent, its reciprocal is cotangent. So their reciprocals are the same sign. So that would be all the different ratios and where they end up being positives or negatives, but it's all controlled by what types of coordinates are in those particular quadrants. All right, so let's see if that makes any sense to us. Here's an example of a question that wants us to find what quadrant is the angle in that we're talking about. So if I had A, it says sine of theta is less than 0. That means sine is negative. Psi, this is how I would do it, psi goes with y. Well, y is only negative down here and here. These are negative y coordinates if you plot your points. Cosine goes with x. So this is saying that cosine, which is x, is bigger than 0. Well, x values are positive over here. So x is positive here or here. Sine, y values were less than 0 down here. So this is saying where were both true. Both were true down here in quadrant 4. So this was describing an angle in quadrant 4. 15,781 degrees. What we should do is figure out the principal angle of this. So we know how to do that. Let's just take out our calculators. Take 15,781, divide it by 360, and I get 43 point something. Get rid of the whole number, and then whatever's left, multiply it by 360, and you'll get your principal angle, 301. Well, 301 is around here somewhere. So it's in quadrant 4. All right, secant. Now we'll make another one of those little diagrams. So secant is a reciprocal of cosine. So cosine goes with x. This is saying where are x's negative? X's are negative here and here. Tangent is the y over the x. So you got to look at both coordinates, and this is saying that it's a negative answer. Well, the only way you can get a negative is if these are opposites. So either one positive and one negative, or switch them, the other one negative, and so either x negative, y positive, or y negative, x positive. Well, that only happens here. It's positive, positive, so tangent's positive. Here it's negative and negative, so tangent's also positive. It's either here or here. There's where both are true. Quadrant number 2. And then D is similar to this one. Find the principal angle. So negative 5375. 5375. Sorry, negative 5375. Divide that by 360. Add 14. Times that by 360. And I get negative 335. I'll get the principal angle, so I'll just add 360. 25 degrees. So this has a principal angle of 25 degrees. Well, that's easy. 25 degrees is here in quadrant 1. Now, if you took, let's say you took this one, and I'll just show you how you say, how do I do it with that other rule you showed me, the cast rule? See if we went C, A, S, T. So you'd say Y, or sine. So sine less than 0. So sine is negative. These are where they're positive. So if it's positive here, it's negative in these two. Cosine positive. So cosine's positive in here. Cosine positive is here and here. Cosine and all. So where both were true, quadrant 4. This one, secant is cosine. It's reciprocal of cosine. So cosine is negative here and here. Put your letters in, C-A-S-T. Cosine's positive here and here because C and A, all, and cosine. So it must be negative in these two. Tangent is positive in these two, and I'm looking for where tangent is negative. So tangent's negative then in the other two. Right? It's positive in 2 and it's negative in 2. So that narrows it down same way, quadrant 2. So hopefully one of those two methods you can now use to figure out where angles will be situated based on whether their trig ratios are positives or negatives. Now, reference triangles have a really important property that you're going to see here in a second. So this is just showing you 4 terminal arms, so 1, 2, 3, 4, and imagine that your reference angle was the same for each one of these. So let's suppose we'll pick a number. Let's say this was 40 degrees, and this was 40 degrees, and then this was 40 degrees, and this was 40 degrees. So the little angle in the corner between the terminal arm and the x-axis and all 4 of these was the same size. So they all have the same reference angle. Now, we're going to find out something about this and say, well, is there anything unique about that? Well, let's get the actual measures of these angles. This would be 40 degrees. Remember, angles are always measured from x around to the terminal arm if you're going positive. So if I looked at this angle on this side, and that little angle there is 40, we know that the whole thing's 180. So if we took 40 out, this angle we're talking about is 140. This is 180 to get to here. This is another 40. So this actual full angle from here around to here would have to be 220 degrees. Now this one, I know that a full circle is 360, but I've got 40 degrees kind of chopped out of it right here, which means this angle back here is 320 degrees. 40, 140, 220, and 320 are all 40 degrees off the x-axis. You say, well, so what? Big deal. Watch this. I'm going to find the sine of 40. I'm going to find the sine of 140. I'm going to find the sine of 220, and then I'm going to find the sine of 320, and something interesting will happen. Here we go. So I'm in degrees. Make sure your calculator's in degrees, and I'm going to find the sine of 40 degrees, and I get 0.6428. 0.6428. I'm going to find the sine of 140. Sine 140 is strange, same thing, 0.6428. I don't even need to use my calculator anymore because I know what's going to happen, but you can check on your calculators. The sine of 220 is negative 0.6428, and the sine of 320 is negative 0.6428. They're the same, except 2 of them are negative and 2 of them are positive. Now that's strange. Look at the 2 that are positive. These 2. Look where their terminal arm is. It's above the x-axis where there are what kind of y's? Now remember, psi goes with y. What kind of y values are up on the top? Positives. Hence, positive trig ratios for sine of 40 and 140. Now your 2 angles are down on the bottom below the x-axis where your y's are negative down in these 2 quadrants. That's why these turned out to be negative. But if you look at the numbers here, they're the exact same. All that happens as you go from quadrant to quadrant when you have the same reference angle is your ratios will perhaps switch signs. 2 of them are going to be negative. 2 of them will always be positive. Now let's take an example of that. Let's take, easy numbers for it to do. Let's take 70 degrees. So let's suppose I wanted a reference angle of 70 degrees. Well, let's draw what the 4 angles would look like. So the first one's easy. That's 70. The second one You want your angle up here. You want this angle to be 70, which means the one you're going to measure on the back side would be 110. So I've got 70 and 110. Draw in quadrant 3 with a 70-degree angle down here. Oops, I don't need that yet. 70-degree angle here, which would make this angle 180 plus 70, 250. And then the fourth version of that would be over in quadrant 4. Same thing, this is 70. The angle on the back side then would be 360, take away 70, 290 degrees. Now, based on what you saw on the last one, I'm going to use cosine this time. Cosine of 70. We're going to do the cosine of 110. We're going to do the cosine of 290. And we're going to do the cosine of, what did I miss here? 70, 110, oh, 250. And we're going to do the cosine of 250 degrees. All of these are associated with a 70-degree reference angle. So they have the same reference angle. Before we go through, let's make a prediction. I think, and I know, you are going to know, hopefully, 2 of these 4 are going to be negative. Tell me which 2 you think are going to be negative. Now remember, we're doing cosine, which is associated with the x-coordinate, because cosine is the x over the r. All right, so we're saying where are the x values on a graph negative? Well, these are negative x values, which means cosine should be negative if your angle is over here or down here. So I'm predicting this one and this one should be negative, and the one in quadrant 1 and the one in quadrant 4 should turn out to be positive because these are positive x values over here. So let's put our calculator to work and see what happens. Cosine of 70. Now they should all be the same, with the only difference being they switch from positive to negatives. Cosine of 70, this one should be positive because it's in quadrant 1 where x's are positive. 0.3420. Find the cosine of 110. So that's over here. Our prediction is this should be negative for cosine. Let's see if we were right. Cosine of 110. Same thing, but negative. So negative 0.3420. Let's go to this one. So 250, which is the one I wrote down last. Our prediction is these are negative x's, so this should come out to be negative. Find the cosine of 250. Same thing. And then finally, let's find the cosine of 290, which is the one over here. X's are positive in quadrant 4, right? Because if you plot points over here, you're going to have a positive, something like, I don't know, 3, -2. But this has to be positive. And cosine is the x over the r. R is always positive. This one comes out to be positive. All right, so now here's what we know. We know that if you have the same reference angle, you're going to get the same trig ratio. The only thing that may happen is it might be negative in one quadrant and then positive in another quadrant based upon, if it's cosine, the x. If it's if it's sine, it'll be based on the y coordinate. And if it's a tangent ratio, it'll be based on the y divided by the x. All right, so here's the types of questions we can now answer. So it says, graph the point, draw the terminal side of angle theta containing this given point, draw a small arc to show the rotation from the initial side, draw a reference triangle. Let me backtrack here for a second. So to make reference triangles is just that, remember, you go from terminal arm down to here, terminal arm down to here, terminal arm always to the x, terminal arm to the x, and that triangle you create is called your reference triangle. All right, so we're going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 6. 5 right there. Oh, sorry, it said 8, -6. My bad. So 8 is here, -6 is down this way. Draw a terminal arm. right out through your point. So here's your point, 8 and -6. Now you make your triangle always down to your x. It's going to be a right angle there. So this side should be 8. This side should be -6. Now, again, we know that it's 6 is the length of it. The negative just indicates it's negative y values down here. So the next thing I need is r. Let's calculate that. Use Pythagoras Theorem. So r squared is 8 squared plus, you don't need to put your negatives in Pythagoras Theorem, 6 squared, because it's the lengths of the sides. So 8 squared is 64, 6 squared is 36, 64 and 36 is 100. So r has got to be the square root of 100, which is 10. So I know that this side is 10. Now, what does it ask us to do here? So we've drawn the we plotted the point, we drew the terminal side, we made our reference triangle through the point. Now it wants the sine, cosine, and tangent. So the sine of theta, theta is always the angle in the corner between the terminal side. It's always your reference angle. So the sine of theta would be -6 over 10. That would reduce to -3/5. The cosine of this angle is 8 over 10, which would be 4 over 5. And now the tangent of angle theta is opposite over adjacent, or y over x, -6 over 8, which would reduce to -3 over 4. All right, now your angle theta, remember they're always measured this way. So what we want to do is figure out this little angle in the corner. Now, it doesn't matter how many times I say this, people don't listen and they screw it up. When you find the reference angle, this angle in the corner, you completely ignore negatives. You don't use them in your calculator. Because as soon as you put a negative in your calculator, you're not going to get an acute angle. Again, I cannot stress enough. Ignore negatives when you're finding the little angle in the corner. So I'm going to pick one of these ratios. Let's say I go with this one. And I'm going to figure out what this angle is. I'm going to go inverse cosine. Now I picked this one because it doesn't have any negatives in it. Inverse cosine of 4/5. So you're going to take your calculator and hit the inverse cosine, which will tell you the angle that has a cosine of 4/5. So shift cosine 4/5 is 36.86. So I'm just going to say 37 degrees. Now that is not the answer for theta. Theta is the reference angle, but your actual rotation angle is measured on the back side out here, because you always start here and go this way. If this little angle is 37, so I should be able to get this angle on the outside, then it should be 323 degrees. Remember, you always start here. If you're going in a positive angle, you go this way. Now I could have that, or I could have it equal to -37. That would be fine, right? Start here and go -37. That would put you there as well. But your answer cannot be 37, because if I said, well, where's 37? Sketch 37. 37 will be up in quadrant 1. 37 is the little angle in the corner called the reference angle, which we use to then figure out the measure of our rotation angle. So hopefully you can keep that all straight. All right, here's another sample. So it's telling me the cosine of some angle is -5/13. And the tangent of the same angle is positive. Greater than 0 means positive. Find the sine of this angle. We need to draw a picture of it. Well, the first thing we got to do is figure out, where do I draw it? Cosine is negative. Cosine, remember, goes with x. Cosine is negative here or here. So I can draw it here or here based on just that. And though, then it says this, tangent, which is the y-coordinate over the x-coordinate, and you have to get a positive. Well, the only way to divide two numbers and get a positive answer is if they're both positive, which would be up here, or if x and y were both negative, that would be down here. That tells me to draw my angle, and you can draw it anywhere down here, doesn't matter. So draw your angle down here. I know it probably won't be to scale, it's not a big deal. Use this to fill in two sides. You're going to make a triangle. You need to know that cosine of an angle is the x divided by the r. And this little angle is always the reference angle. So the x is -5. Remember, r is always positive, meaning I now need to figure out this missing side, y. Y squared is the hypotenuse squared. Subtract your other side squared. So in this case, that will be 169 minus, it's about 9, minus 25, which is 144. The square root of 144 is 12. So this side is 12. Now I always then get students to look at this and say, well, what kind of y's are down here? Negatives. So put a negative on that number. And the sine of theta is, you read it off of this triangle, the sine of theta is -12, because that's the y, over the r, which is 13. Now I know this didn't ask, but I want you to do this for me. I want you to figure out the measure of the rotation angle that would be situated down here that goes with this triangle. Okay, I'm going to do this time. I'm going to go inverse tan. Remember, you always got 6 choices here. Any of your 6 trig ratios. I'm going to use inverse tan, which is opposite over adjacent, or y over x. But notice what I don't do when I'm finding, this is to find the reference angle, which is the little angle in the corner. I don't put any negatives in here. It's 12 over 5. I'm going to figure out that little angle in the corner. So I'm going to go second function tan to get my inverse tan of 12 over 5. And that will give me, inverse tan of 12, 67 degrees. Now that's not the answer. 67 degrees would be in quadrant 1. That's the little angle in the corner right here, the reference angle. That's 67 degrees. Now we take our little bit of knowledge of rotation angles and say, well, from here to here is 180, and then this angle is 67, so 180. So this angle out here is 180 plus 67, which would be 247 degrees. If you went the other way, which you could go this way instead, then it would be, so if I went that way, it'd be negative 180, but there's 67 cut out of the corner, so it could also be negative 113, negative 113 degrees would also be in the same place. Remember, the name for that is coterminal. All right, let's try another one. So we've got, so this would be a good spot to pause the video and try it on your own. So we need to figure out where to draw our angle first. So I always like to draw my little thing over here. So cotangent is negative. So this is the x over the y for cotangent. So when I divide the x and the y, I'm getting a negative. That can only happen if one's positive and one negative, which is there or over here. Cosine is negative, where x is negative, which is here or here. So that's telling me to draw my angle out here. Make a reference triangle, always down to your x-axis. This little angle is your reference angle. This is giving you two sides. Cotangent is the x over the y. So the x is 15. The y is 8. Now look this over and say, well, how come it's negative? It's negative because the x's are negative here and the y's are positive. We need to figure out the r value. Now I'm going to start doing this a bit quicker. So the r value is going to be this squared, so 8 squared plus 15 squared. And then you have to take the square root of that to get r. So 225 plus 64. And then I need the square root of that. 17. So this side is 17. The cosecant of an angle is always the reciprocal of sine, right? So as long as you know sine of an angle is y over r, cosecant is the r divided by the y, r and y. So there's the answer for the cosecant. So let's figure out this angle, even though it wasn't asked. Let's figure out what this angle is. So to do that, we're going to figure out this angle in the corner. Remember, do not put negatives in your calculator. Let's go, I'll use tan again. Inverse tan, and you can pick any ratio you want. I'm just going to go with tan, 8 over 15, and that'll give me the little angle in the corner. So inverse tan of 8, oh, I keep forgetting my brackets. Inverse tan of bracket 8 divided by 15 is equal to 28 degrees. So that's the little angle in the corner. Again, that's not our answer. So this angle out here then, if that angle's 28, is 180 minus 28, which would be 152. Or if you came in the other direction, it would be negative 180 and then a negative, or another 28 degrees, so negative 208. Would also be coterminal in the same place. This is one I just took off a test question from last year, so we'll kind of finish with this one. It says, given that tan theta is negative radical 5 over 7 and cosecant theta is less than 0, determine the exact value of secant theta in simplest form. So let's figure out where to draw this first. Alright, so tangent, remember, is the y over the x. These are just, you need to know these. You can see we're using them a lot. Y over x is a negative. So tangent can only be negative here and here. That's where the y and the x are opposite sides. Cosecant, which is the reciprocal of the sine ratio, and we know that the sine ratio is attached to the y coordinate. So this is telling me that the y coordinates are less than 0, which is negative. Well, y's are only negative down here and here. So we know we are in quadrant 4. Make a triangle. Little angle in the corner is our reference angle. Now, the two sides we're given here, if it's tangent, would be the y and the x. Oh, x, sorry, which is here. These are positive. These are negative, hence the reason tan was negative. I need to find the r value. Use Pythagoras Theorem. So r squared is 7 squared, 49, plus the square root of 5 squared, which is 5. So r squared is 54. The radius would be the square root of 54. Now notice it said here simplest form. This is the reason it said that. We learned in radicals in pre-calc 11, you cannot leave it like that. So that's 9 times 6, right? Square root 9 times 6. That would be 3 radical 6. So this side, the exact value, they don't want you to put that in your calculator and figure out what it is when it says exact, is that. So I'm looking for secant. So the secant of theta, secant, which is the reciprocal of cosine. Cosine is x over r, so secant is r over x. 3 radical 6 over 7. And that is the exact answer in simplest form. Now, it wants us to find theta in standard position. Standard position means measuring it from here. Now, it's telling us which one it wants. It wants theta to be somewhere between negative 360 and 0, which means it wants your answer to be negative, which is fine. We'll figure that out here. So we're going to first just figure this angle out. Pick a trig ratio. Again, I like tangent. It's fairly easy to use. So the inverse tan is root 5. Notice what I'm not doing. I'm not putting the negative in my calculator to find the little reference angle in the corner. So this little angle will be, so I am inverse tangent of square root 5. I gotta watch brackets here. Square root 5, close that off, and then divide that by 7. And you should get 17.7, so 18 degrees. And again, double check, make sure you know how to do this on your calculator, how to type in the radicals and all that good stuff. I should get 18. So this little angle here is 18. So one answer would be 342 degrees. However, that is not the answer they're looking for. They want your angle to be between 0 and negative 360. So they want this angle start this way and go this way. Well, that's going to be easy. It'll just be negative 18 degrees. So the angle they're talking about here is negative 18 degrees. Remember, this is just the reference angle, the little one in the corner, and then depending on what they ask us, we'll go either in the positive direction or the negative direction and come up with our rotation angle in standard position. That's what they mean by standard position. Measure from the positive x, either in the negative direction or in the positive direction until you hit your terminal arm. This is like the first example we did. So this would be another, you've got a point, so negative 5, 7, and you don't have to measure it off, just get you in the right quadrant. So negative 5 and 7. Make a terminal arm that goes out through that point. Turn it into a reference triangle. X is negative 5. Y is positive 7. You need to calculate the R value. So R would be x squared, which is 25. This squared, which is 49. Then you got to take the square root of it to get R. So 74. I don't believe there's any perfect squares that go into 74, so it's reduced. It wants all 6 ratios. So this side now is square root 74. So sine of theta would be, remember that theta is the little reference angle down here. So this little angle has all the properties of your rotation angle. So sine of theta is 7 over the square root of 74. The cosine of theta would be negative 5 over the square root of 74. The tangent of theta would be 7 over negative 5, so negative 7/5. And then your reciprocals, so reciprocal of sine is cosecant. Just flip the ratio, root 74 over 7. Reciprocal of cosine is secant, flip the ratio, negative root 74 over 5. And cotangent, flip the ratio, negative 5 over 7. Okay, so B wants us to now figure out the angle. Now this one's getting real tricky. It wants the angle to be somewhere between 360 and 720. So they want it to be positive, but they want it to actually be in that second rotation, which is fine. We can figure that out. Start always the same as every other time. Get the reference angle. So when you find the reference angle, pick any trig ratio you want. So I'm going to go inverse tan again. Be 7 over 5. Notice, no negative. On my calculator, I will go inverse tan of 7 over 5. And I get 54 degrees. So the little angle in the corner is 54, right here. So what I'm going to do next is figure out this angle. So if that's 54, this must be 180, take away 54, so 126. I go here and say, that can't be the answer though, because it's not between 360 and 720. So they're now making us remember stuff from earlier about coterminal angles. So well, how do I get another angle in the same place as this one, just add 360. So we're going to take the angle that we just found and we're going to add 360 degrees, and that's going to give us 486 degrees, which would be in the exact same place as this, and it would be between these. So angle A they're talking about is angle 486 degrees. Now this is a really good question, and this is the last two have been right off of old tests. So this is kind of the level of difficulty that you've got to be able to deal with come test day. And we've done an example of that already. So I think that's enough for our trigonometry of rotation angles. So hopefully you're getting comfortable after watching this look at reference triangles, reference angles, whether trig ratios are positive or negative based on where they're drawn, and how to find reference angles and use that to then find angles in standard position. All right, thanks for watching. As always, reach out if you have any questions, and we can hopefully get them cleared up for you.